In a couple of previous videos, I first showed DC control of 24-volt solenoid valves. Then I showed DC control by electronics. Well, in this video, I've now taken my 177 BB cannon and I've modified it to have the 555 based variable pulse width valve controller on it. Also, this cannon in previous videos had this pink colored valve on it. This proved to be not a good choice, as although this valve apparently has a 1/4 inch port, you can just see it inside there. When it turns up to the valve sealing surface, the sealing surface shrinks down to 1/16. I'd been wondering why, with this particular valve, I was getting only 480 to 500 feet per second velocities at 500 psi. By changing to this new valve that I'll zoom in on here, that's the new valve I've switched to. At 500 psi, I'm getting around 800 feet per second now, which is a lot better. So this 177 BB air cannon is very considerably upgraded now, and it's performing a lot better with the new 24-volt solenoid valve and electronic driver for it. Over here, I assembled the 555 timer circuit and the MOSFET that operates the solenoid into a little box that I can reach easily. The potentiometer that sets the pulse width is right here. Max is all the way clockwise, and minimum, which gives you maybe 100 feet per second on your BB, is all the way over counterclockwise. This crowded, messy little area here underneath the breech forms the cannon's power supply. There's a 24-volt AC transformer that works off the 120-volt AC mains. It also has an 8-volt winding on it, this particular transformer. The 8-volt winding is driving this single diode and filter capacitor here, producing 11 or 12 volts to run the 555 timer circuit. These other two large capacitors, totaling about 1500 microfarads, have their own rectifier, and they're running off the full 24 volts AC, which when rectified and filtered gives around 36 volts DC to operate the solenoid valve. With these two modifications, the new, much more efficient 24-volt solenoid valve, coupled with the 555 based electronic controller, have made this cannon much more fun, much more efficient to use. Well, everything's hooked up. Let's load a BB into the breech, turn on the compressor, get some pressure, and we'll fire a test shot or two. Or maybe a couple of test shots. The target is a steel can 10 meters downrange. As you can see, firing is very reliable, even though I'm shooting at 350 to 400 pounds pressure continuously. The breech of this cannon can also chamber normal lead air rifle pellets. Despite the smooth bore, these seem to shoot quite accurately. They seem to fly nose forward on their own, despite the lack of rifling, and strike the target point first, rather than keyholing. Interesting. I'll now fire a few 177 lead pellets out of this cannon. As you can see, they're pretty much as easy to load and fire as a BB. Well, I'm going to go and grab the can so we can have a look at it. It's 10 meters downrange. I'll go get it and bring it back to the camera. This is a steel, or it was a steel half-quart paint can. Not a thin aluminum can, but rather a good quality steel can that once held a petroleum-based stain product. Well, it won't hold much of anything anymore, because both the lead air rifle pellets and the steel BBs go right through both layers of steel, front and back, and embed themselves firmly in the wooden backstop. The new electronic controls and the new valve have given this cannon a new lease on life, more velocity, more power, and it's more fun to shoot it. Here's a look downrange. And there's that can and its wooden backstop. Here's kind of a shaky view through the scope of one shot. Here I've attached the 250 round tubular clip for steel BBs, seen here, so that I can try out semi-auto fire. As you can see from the condition of the wood backstop, I've already put a couple of clips through this thing just for fun, so I'll try for a video of this already partly ruined can. Oops, just ran out of ammo. That didn't last long. Well, let's try another half clip. Out of ammo again. Oh well. Yeah, let's have another go. Another clip. Out of ammo. I should have shown the setup for that previous semi-auto clip, but here it is, and I'm going to shoot again on aggressive semi-auto. The high pressure air system is right now pumping up the air tank. You can see at the bottom left, the air tank's manifold is in turn connected to the 177 air cannon through that coily black hose you can see. So in the previous semi-auto shooting clip and in the next semi-auto shooting clip, I've been working off a steady pressure of 425 to 450 psi. Well, we've got 450 psi in the tank, so let's have another clip of semi-auto. See if we can hit the can at 10 meters distance. Shot it right off. Won't even get to finish my clip. I had put one can inside the other to try and make them more durable, but as you saw, so much for that. The semi-auto fire at high velocity and a high rate of fire, well, these cans, they're ruined. Awesome. This target is a triangular-shaped piece of 040 thick aluminum stock, painted white, left over from a sign or something. I don't need it, so it's a semi-auto test target. Yeah, pressure will be around 475 psi, running off the high-pressure air tank to give us stable air. Out of ammo. Well, the high pressure air tank's back up to 450 psi, so let's fire one more clip at this 41 thousandths of an inch thick old aluminum sign piece. I think I'm out of ammo again. Well, I've brought the camera down to the target area, so let's have a look. Well, it's quite obvious that not every BB went through this aluminum plate that's 41 thousandths thick, but they did leave deep dents. Some of them did penetrate. Generally, this target's in pretty bad shape now, and that cannon is now a really enjoyable piece of equipment.